Humans were never the only kind of human on Earth. For most of our history, the world was shared. In cold valleys, dense forests, tropical islands, and dry grasslands, other human species walked, hunted, rested, and watched the same skies we still look at today. Some were stronger than us. Some survived brutal climates for hundreds of thousands of years. Some buried their dead. Some may have made art. And yet, one by one, every other human line disappeared until only we remained. The strange part is not that they vanished. The strange part is that for a brief moment in time, your ancestors could have stood face to face with another kind of human and recognized something familiar in their eyes. If humanity was once a crowded family instead of a single species, then what exactly made us the last ones left? For most people alive today, the word human feels singular. It points in one direction only, one species, one surviving line, one kind of mind looking back at the past and calling itself humanity. Schools, museums, films, and books often tell the story this way. There were ancient creatures before us, and then eventually there was us. The final result, the only humans left standing. But the deeper scientists looked into old bones, ancient caves, buried tools, and fragments of preserved DNA, the stranger the story became. Humanity was never a single voice moving alone across history. For most of the human story, Earth was shared by different kinds of humans living at the same time. Some walked through frozen valleys in Europe, while others crossed dry African grasslands. Some survived on isolated islands, surrounded by dangerous oceans. Others disappeared long before our own species had fully spread across the world. The image most people carry in their minds, a lonely line of progress leading directly to modern humans, now appears far too simple. The real story looks less like a straight road and more like a tree filled with branches, many of which are now gone forever. Around 300,000 years ago, Homo sapiens emerged in Africa. That date can sound impossibly distant, but in evolutionary terms, our species is surprisingly young. Long before Homo sapiens existed, other human species had already survived harsh climates, migrated across continents, created tools, and adapted to environments that changed again and again over thousands of generations. Some of them endured for periods of time far longer than our species has existed so far. Homo erectus, for example, survived for well over 1 million years. That means an entire human species once walked the Earth for a span of time so vast that modern civilization, agriculture, written language, and recorded history would barely occupy the final seconds of its existence. This changes the emotional shape of human history. It suggests that being human was never a fixed condition. Different human species had different bodies, different strengths, different ways of surviving. Some were shorter and more heavily built. Some had larger brow ridges or wider faces. Some likely spoke differently from us, if they spoke at all, in ways we would recognize. Yet they were not animals standing outside the human story. They were part of it. They belonged to the same larger family we came from. They used hands shaped much like ours. They raised children. They searched for food. They slept beside fires during cold nights. They watched weather move across the sky without understanding what the future would bring. At certain moments in prehistory, several human species may have existed on Earth at once. If someone could travel back far enough into the past, they might not find a world occupied by one humanity, but many. A traveler standing in one valley could encounter a group of humans completely different from another group living hundreds of miles away. Some populations would disappear, others would survive for thousands of years longer. New branches would emerge while older ones slowly faded. Evolution did not move with a plan. It experimented continuously, generation after generation, through climate shifts, isolation, migration, hunger, disease, and time. The unsettling part is that if we had lived beside these other humans long enough to truly know them, we might not have seen them as entirely separate from ourselves. A face can look unfamiliar while still carrying traces of recognition. A voice can sound strange while still expressing fear, caution, or care. Somewhere in the distant past, ancient humans may have looked at one another with the same uncertain curiosity. Not fully the same, not fully different. And for a long stretch of time, none of them could have known which human species would eventually remain alone on the Earth. It is easy to imagine the ancient world as mostly empty, vast forests without footprints, endless plains without voices. Small groups of early humans moving silently through an enormous wilderness with no awareness of anything beyond their own tribe. In some places, that was true. Human populations were often extremely small compared to today. But small populations do not mean a simple world. During different periods of prehistory, multiple human species existed at the same time across different regions of Earth, sometimes separated by mountains, deserts, ice, or oceans, and sometimes close enough that their paths may have crossed. The farther scientists studied the fossil record, the more crowded the human story began to look. The old image of evolution, once shown in textbooks, a neat line from ape-like ancestors gradually becoming modern humans, no longer reflects what researchers believe happened. Evolution did not steadily march toward Homo sapiens, as if everything before us were merely unfinished versions of ourselves. Instead, many human species appeared, adapted to local environments, survived for long periods, and then disappeared. Some branches ended quickly. Others lasted for hundreds of thousands of years. A few overlapped with our own species. The result resembles a dense network of relatives rather than a single chain of progress. Around the same time that early Homo sapiens lived in Africa, Neanderthals occupied parts of Europe and Western Asia. They were adapted to colder climates, with strong bodies that conserved heat and powerful muscles that helped them survive difficult conditions. Farther east, another mysterious human group now called Denisovans lived across parts of Asia. Scientists know surprisingly little about how they looked, because only small fragments of bone and teeth have been found, yet their DNA still survives in some modern populations today. On islands in Indonesia, a much smaller species called Homo floresiensis survived in relative isolation. Standing only about 1 meter tall, they challenged long-held assumptions about what a human species could look like. Meanwhile, in Africa, species such as Homo naledi displayed combinations of ancient and surprisingly advanced traits that scientists are still trying to understand fully. These human species did not exist one after another in perfect order. Many shared the world simultaneously. At certain points in prehistory, Earth may have contained several kinds of humans living under the same sky. That reality changes how we think about our own identity. Today, humanity appears unified because only one human species survives. We grow up surrounded entirely by Homo sapiens, so the idea feels natural, but for ancient humans, encountering another kind of human may not have been impossible or even rare in some regions. Different bodies, different faces, different voices, perhaps different ways of thinking, all existing within the larger category we now call human. No modern experience truly compares to this. The closest examples in today's world are differences between cultures, languages, or appearances, but every person alive now still belongs to the same species. Prehistoric Earth was stranger than that. The boundary between us and other humans was once much less clear. Scientists continued debating exactly how these groups interacted. Some evidence suggests competition over resources. Other evidence points toward occasional cooperation or interbreeding. Ancient DNA has shown that Homo sapiens and Neanderthals had children together. This means the separation between species was not always absolute. The human family tree was not composed of sealed branches growing independently forever. Sometimes branches touched again, sometimes they mixed. Sometimes entire populations vanished while traces of them quietly continued inside future generations. Looking back across this deep history creates an unusual feeling. Modern humans often see themselves as separate from nature, as though civilization lifted us away from the long biological story that shaped every living creature. Yet the existence of multiple human species reminds us that Homo sapiens is not the center point of evolution. We are one surviving branch from a much larger family whose members adapted, struggled, migrated, and disappeared over immense stretches of time. For thousands upon thousands of years, being human did not mean being alone. It meant sharing the earth with other minds that were close enough to resemble us, yet different enough to remind us how fragile our own place in history may be. Modern humans rarely think about how unusual our current world truly is. Everywhere on Earth, from the largest cities to the most isolated villages, every person belongs to the same species. Languages change, traditions change, faces and cultures differ across continents. But biologically, humanity is remarkably unified. A child born in one part of the world could eventually have children with someone from the opposite side of the planet. This feels so ordinary that most people never stop to question it. Yet for most of prehistory, the situation may have looked very different. The ancient world was not occupied by a single humanity moving together through time. It was occupied by multiple human groups whose relationships were far more complicated than the categories modern people use today. Some scientists believe ancient humans may not always have understood one another easily. Different species likely carried different physical abilities, survival strategies, and perhaps even different social behaviors. One group may have specialized in surviving cold environments. Another may have adapted to dense forests or coastal regions. Some may have traveled long distances regularly, while others remained tied to smaller territories for generations. Evolution shaped each population according to local pressures that changed slowly over thousands of years. Food availability, predators, disease, climate shifts, and geographic isolation all pushed human species in different directions. There was no final design waiting at the end, only survival, repeated endlessly across time. This makes the disappearance of the other human species feel stranger the more closely it is examined. When people hear about extinction, they often imagine creatures completely unrelated to themselves. Dinosaurs, mammoths, giant reptiles, unfamiliar animals buried deep in Earth's past. But extinct human species create a different emotional reaction because the distance feels smaller. Neanderthals were not distant beasts wandering outside the human experience. They created tools, controlled fire, and survived brutal ice age conditions for hundreds of thousands of years. Evidence suggests they cared for injured individuals who could not survive alone. Some archaeological sites hint at symbolic behavior and possible rituals surrounding death. These details matter because they slowly erode the old belief that intelligence, emotion, and social complexity belonged only to Homo sapiens. The more evidence scientists uncover, the harder it becomes to place a clean dividing line between them and us. Even the word human begins to feel unstable when viewed across deep time. If several human species existed together, where exactly should the boundary be placed? Was humanity defined by intelligence alone? Tool use, language, emotion, cooperation, burial practices, adaptability? Every trait once considered uniquely human has gradually become more complicated as new discoveries emerge. Some extinct human species possessed abilities once believed exclusive to modern humans. Others combined primitive and advanced traits in ways researchers still struggle to explain clearly. The deeper the past is explored, the less tidy the story becomes. There is also something quietly unsettling about realizing how temporary every human species has been. Most no longer exist. Entire populations survived for immense stretches of time before eventually disappearing. Some vanished slowly as numbers declined generation after generation. Others may have been absorbed into neighboring populations through interbreeding. Climate changes reshaped environments repeatedly, forcing migrations, isolation, and competition. Survival was never guaranteed. From the perspective of deep history, extinction appears less like an exception and more like the normal outcome for human species. Homo sapiens may simply be the latest surviving branch, not the permanent destination evolution was building toward. Yet because we are the only human species left, we experience the world in complete biological solitude. No modern person has ever looked into the eyes of another human species. No living memory contains the experience of sharing the planet with minds that were close relatives, but not entirely the same. That ancient reality disappeared long before recorded history began. Only fragments remain now, weathered bones, broken tools, traces of ancient fires, and small pieces of DNA carried silently inside modern bodies. These remnants suggest that the human story was once far more crowded, uncertain, and interconnected than most people realize. Before Homo sapiens spread across the globe, before cities, kingdoms, religions, and written language, there was a world where humanity existed in many forms at once. And for reasons still not fully understood, every other branch eventually faded until only one remained to remember the others. Long before the first cities rose from the ground, before language took written form, before humans crossed oceans or built permanent homes, our ancestors lived in a world that did not belong to them. Africa, millions of years ago, was filled with powerful animals moving through changing landscapes. Giant cats rested in tall grass. Herds migrated across open plains. Forests expanded and retreated as climates shifted slowly over enormous stretches of time. Early human ancestors were not dominant creatures in this environment. They were small, vulnerable primates trying to survive among predators far stronger and faster than themselves. The beginning of the human story was not marked by power. It was marked by adaptation. One of the earliest important changes was walking upright. Ancient ancestors, known as Australopithecines, began moving on two legs several million years ago. Species such as Australopithecus afarensis still carried many ape-like traits. Their brains were relatively small, their arms remained useful for climbing, and their lives were likely tied closely to both trees and ground environments. Yet something fundamental had already changed. Walking upright freed the hands, altered the spine and hips, and slowly reshaped how these early ancestors interacted with the world around them. Scientists still debate exactly why bipedal movement became so important. It may have helped conserve energy during long-distance travel. It may have improved visibility across open landscapes. It may have allowed better carrying of food or infants. The full answer remains uncertain. But once this shift began, the future direction of human evolution changed with it. These early ancestors were not truly human in the modern sense, yet they stood near the beginning of a long evolutionary process that would eventually produce many human species. Over time, climates across Africa continued changing. Forested regions shrank in some areas while open grasslands expanded. Environmental instability forced ancient populations to adapt repeatedly. Some groups disappeared. Others survived by developing new behaviors and physical traits. Around 2.5 million years ago, the first members of the genus Homo began to emerge. This transition was gradual, not sudden. Evolution does not create sharp boundaries overnight, but species such as Homo habilis displayed important differences from earlier ancestors. Their brains were somewhat larger, their teeth and jaws changed. Most importantly, evidence suggests they used stone tools with increasing consistency. These tools were extremely simple compared to modern technology. Sharp flakes broken from stones could cut meat, scrape hides, or process plant material, yet even basic tools represented a profound shift in how early humans survived. Instead of relying only on physical strength, they increasingly altered their environment through learned behavior. Knowledge could now accumulate slowly across generations. A useful technique discovered by one group might continue long after the original individual died. This ability would eventually become one of the defining characteristics of the human lineage. Early Homo species still lived difficult and dangerous lives. They were not fearless hunters dominating the landscape. In many cases, they likely scavenged animal carcasses left behind by predators. Their survival depended on cooperation, awareness, memory, and adaptability rather than brute force. Every small advantage mattered. The ability to shape a stone edge more effectively, recognize seasonal food sources, or communicate danger quickly could determine whether a group survived another year. What makes this stage of human evolution especially important is that it opened the door to diversity within the human family. Once the genus Homo appeared, different populations began adapting to different pressures in different environments. Over immense spans of time, separate branches emerged. Some would remain confined to particular regions, others would migrate far beyond Africa. New species would rise, while older ones vanished. The human story was beginning to spread outward into multiple forms. Looking back now, these early ancestors can seem distant and unfamiliar. Their world lacked nearly everything modern people associate with civilization. Yet, many of the traits that later connected all human species were already forming quietly during this period: cooperation, memory, learning, tool use, endurance, and adaptation to unstable environments. The foundations of humanity were not built in comfort or certainty. They emerged slowly through generations of survival in a world that constantly changed faster than any individual could fully understand. The first stone tools humans left behind appear almost unimpressive when viewed today. Small, broken rocks, sharp flakes, rough cutting edges shaped by repeated strikes against harder stones. To modern eyes, they can look accidental, even primitive. Yet these simple objects mark one of the most important turning points in the history of humanity. They represent a moment when survival began depending less on physical anatomy alone and more on learned behavior passed from one mind to another. Around 2.6 million years ago, some early human ancestors were already creating what scientists now call older one tools. These tools are strongly associated with species such as Homo habilis, though researchers continue debating exactly which groups first developed them. The tools themselves were simple but effective. A sharp stone edge could cut meat from bones, break open marrow, process plants, or shape wood. Tasks that bare hands and teeth struggled to accomplish suddenly became easier. The environment itself had started to become something early humans could manipulate intentionally. This mattered because the human body was never specialized, like the bodies of many other successful predators. Humans lacked claws, thick fur, massive teeth, or great speed. Instead, survival increasingly depended on flexibility. Tools extended the body's natural abilities. A sharpened stone became a cutting tooth stronger than flesh. A shaped branch became an extended arm. Over countless generations, this pattern would continue. Humans survived not by becoming physically dominant animals, but by continuously reshaping the world around them through learned behavior. The brains of early Homo species were still small compared to modern humans, yet they were already larger than those of earlier Australopithecines. Brain expansion alone did not instantly create intelligence in the modern sense. Larger brains also require more energy, more food, and longer periods of development during childhood. These biological costs only make sense if the advantages are significant enough to improve survival. In the unstable environments of prehistoric Africa, memory, planning, cooperation, and tool use likely became increasingly valuable. A group capable of remembering water sources during dry seasons or recognizing migration patterns among animals held important advantages over groups that could not. The growing relationship between the brain, hands, and social learning slowly changed the direction of human evolution. Knowledge no longer disappeared entirely when an individual died. Behaviors could be observed, repeated, and improved. Even very basic cultural transmission created a new type of survival strategy. This process unfolded slowly beyond anything a single generation could notice. But across hundreds of thousands of years, tiny improvements accumulated. More effective tools led to new food sources. Better nutrition may have supported further brain growth. Larger social groups encouraged more communication and cooperation. Each change influenced the others in ways scientists are still trying to fully understand. Importantly, these developments did not produce one perfect human species moving steadily toward Homo sapiens. Instead, they created conditions where multiple branches of the human family could emerge. Different populations faced different environments and pressures. Some groups adapted to hotter, open grasslands. Others survived in woodland regions. Isolation separated populations for long periods, allowing evolutionary changes to accumulate independently. Once the genus Homo began spreading across Africa, diversification became increasingly likely. Evolution experiments whenever populations separate and face different challenges over enough time. Some branches would eventually disappear without leaving descendants. Others would contribute to future human species in complex ways. The deeper scientists study early human evolution, the clearer it becomes that there was never a single inevitable path leading directly to modern humans. Many forms of humanity existed because many solutions to survival were possible. This idea can feel strangely humbling. Modern people often imagine themselves at the top of a completed ladder of progress, but the earliest human story does not resemble a ladder at all. It resembles an uncertain landscape filled with temporary adaptations, shifting climates, and fragile populations trying to survive one generation after another. Some lineages lasted astonishingly long periods before vanishing. Others change so gradually that no clear dividing line exists between one species and the next. Humanity was not built according to a blueprint. It emerged through countless small adjustments shaped by time, chance, geography, and survival. And somewhere within those early populations carrying simple stone tools through ancient African landscapes, the foundations were forming for a future world where many different human species would eventually walk the earth together. For hundreds of thousands of years, early human populations remained tied mainly to Africa, the continent where the human story first began. Generations lived and disappeared beneath changing skies, without knowing that their descendants would eventually spread across nearly every part of the planet. The world beyond their familiar territories was immense, dangerous, and unknown. Mountains, deserts, coastlines, forests, and colder northern climates created barriers that no earlier human ancestors had successfully crossed on a large scale. Yet slowly, almost invisibly at first, something within the human lineage was changing again. Bodies became taller and more efficient for long-distance movement. Brains continued expanding. Tool-making grew more refined. Social cooperation deepened. One branch of humanity was beginning to develop the ability to travel farther than any human species before it. That branch would later be known as Homo erectus. Emerging around 1.9 million years ago, Homo erectus marks one of the most important turning points in human evolution. Earlier human species had already begun adapting to life on the ground and using simple tools, but Homo erectus carried these developments much further. Their body proportions looked more recognizably human than many earlier ancestors. They had longer legs, shorter arms, and bodies better suited for endurance walking across large distances. This may seem like a small detail, yet it transformed the relationship between humans and geography. A creature capable of traveling farther could search for new food sources, follow migrating animals, escape environmental pressures, and eventually move into entirely unfamiliar regions. For the first time in human history, a human species began leaving Africa in significant numbers. Fossil evidence shows Homo erectus populations spreading into parts of Asia and possibly Europe over enormous stretches of time. This migration did not happen as a single organized journey. No one stood at the edge of a continent planning to conquer the world. Movement occurred gradually across countless generations. Small groups expanded into nearby territories. Children grew up farther from the places where their ancestors had lived. Over thousands of years, those movements accumulated until human populations occupied lands no earlier members of the genus Homo had reached before. The world was becoming connected by human presence in ways never seen previously. Homo erectus also appears linked to major advances in tool-making technology. Their stone tools became more symmetrical and carefully shaped than earlier Oldowan tools. Hand axes associated with Acheulean technology required planning and repeated craftsmanship. Creating such tools involved more than random strikes against rock. It demanded attention to shape, purpose, and technique. This suggests increasing cognitive complexity and possibly more advanced teaching within social groups. Knowledge was becoming something preserved and refined across generations rather than rediscovered repeatedly from the beginning. Another important change may have involved fire. Evidence remains debated in some cases, but many scientists believe Homo erectus likely learned to control fire at least hundreds of thousands of years ago. Fire altered human existence profoundly. It provided warmth during cold nights, protection from predators, and access to cooked food that was easier to digest. Cooking may have increased the nutritional value humans extracted from meals, potentially supporting further brain development over evolutionary time. Fire also changed social life. Groups gathered around shared light and heat after darkness fell. Time once limited by sunset expanded into longer periods of interaction, observation, and learning. The human relationship with the environment had entered a new stage. What makes Homo erectus especially important to this story is not only their survival skills, but their extraordinary longevity as a species. They survived for more than 1 million years, far longer than Homo sapiens has existed so far. Entire climate cycles passed, while Homo erectus populations continued adapting and enduring. This challenges the quiet assumption modern humans often carry, that survival today somehow proves superiority. Evolution does not reward species based on intelligence alone. It rewards survival within changing environments. By that measure, Homo erectus was one of the most successful human species that ever lived. And as their descendants spread into new lands and became separated across vast distances, the stage was slowly being prepared for even more branches of humanity to emerge. The crowded world of many human species had not fully arrived yet, but its foundations were already spreading outward across the earth. If modern humans could travel back far enough into the past, there is one ancient human species they would likely encounter across enormous stretches of the world: Homo erectus. For a very long period of prehistory, Homo erectus was not a small experimental branch struggling briefly before extinction. They were widespread, adaptable, and remarkably durable. Their story lasted so long that the rise and fall of entire human civilizations today would appear tiny by comparison. Long before Homo sapiens painted caves, built cities, or crossed oceans, Homo erectus had already survived shifting climates, changing landscapes, and migrations across continents over spans of time difficult for the modern mind to fully imagine. The name Homo erectus means upright human, reflecting the more modern body structure this species possessed compared to earlier ancestors. Their legs were longer, their stride more efficient, and their bodies better suited for traveling great distances under the open sky. Scientists believe endurance may have become one of their greatest strengths. Unlike many predators that rely on short bursts of speed, humans evolved bodies capable of sustained movement over long periods. Homo erectus likely spent much of life moving through landscapes in search of food, water, safety, and opportunity. Their world demanded constant adaptation. Forests expanded and vanished, grasslands shifted, ice ages slowly altered climates over thousands of years. Survival depended on flexibility rather than stability. Fossils connected to Homo erectus have been discovered across a huge geographic range, including parts of Africa, Georgia, China, and Indonesia. This wide distribution reveals something extraordinary. Homo erectus was the first human species known to spread far beyond Africa successfully and maintain populations across distant regions for immense periods of time. No earlier human species had achieved this scale of expansion. Their migrations happened slowly, generation after generation, but the result permanently changed the relationship between humans and the planet. Humanity was no longer confined to one continent. The species had begun adapting to many environments at once. This geographic expansion also meant separation. Populations living far apart experienced different climates, different food sources, and different survival pressures. Over time, isolation allowed evolutionary differences to accumulate. Some scientists believe later human species may have emerged partly from these separated Homo erectus populations, adapting independently across regions. In this way, Homo erectus may stand near the center of a much larger human story, not because they were the final destination of evolution, but because they opened pathways that led to many future branches of humanity. Daily life for Homo erectus was demanding and uncertain. They lived without agriculture, written language, permanent settlements, or advanced shelter. Every meal required effort. Injuries could become fatal. Predators remained a constant threat in many regions, yet archaeological evidence suggests they were far from helpless. Their stone tools became increasingly refined over time. Acheulean hand axes associated with Homo erectus reveal symmetry and intentional design. These tools were useful for cutting meat, breaking bones, processing plants, and shaping materials. The repeated appearance of similar tool styles across distant regions suggests cultural learning and knowledge transmission within groups. Fire may have transformed their lives even further. Though evidence remains debated at some sites, many researchers believe Homo erectus learned to use controlled fire hundreds of thousands of years ago. Fire changed nights. It extended waking hours beyond sunset and created safer gathering spaces protected from some predators. Cooked food softened meat and plants, making digestion easier and potentially increasing available calories. Around a fire, early humans may also have strengthened social bonds through shared attention and communication. Even without language in the modern sense, cooperation likely became increasingly important. No individual could survive alone easily in such harsh environments for long. Perhaps the most astonishing fact about Homo erectus is simply how long they endured. Estimates vary, but Homo erectus survived for well over 1 million years. Homo sapiens, by comparison, has existed for roughly 300,000 years so far. Modern civilization occupies only a tiny fraction of that period. This perspective changes the meaning of human success. Today, People often assume technological advancement proves evolutionary superiority, but evolution measures survival differently. A species that survives changing climates and environmental instability for over 1 million years represents extraordinary success by biological standards. Homo erectus was not a failed version of us waiting to disappear. For most of human history, they were among the greatest survivors the human family ever produced. And somewhere within the immense stretch of their existence, new human branches slowly began forming that would one day share the earth together. To understand why Homo erectus survived for such an immense span of time, it helps to imagine the kind of world they inhabited. Nothing remained stable for long. Temperatures rose and fell across thousands of years. Wet regions slowly dried. Grasslands replaced forests, then retreated again. Animal populations migrated with the climate, forcing human groups to adapt continuously or disappear. Unlike modern people, Homo erectus could not store food for long periods, build insulated cities, or escape environmental pressures through technology. Survival depended on movement, memory, cooperation, and the ability to adjust behavior before changing conditions became fatal. Their bodies reveal part of this adaptation. Homo erectus possessed long legs and narrow hips that made walking and traveling over great distances more efficient. Scientists believe endurance became one of their defining advantages. While many animals outrun humans over short distances, humans excel at sustained movement. A group capable of tracking animals for hours beneath the heat of the sun could eventually exhaust prey that relied on bursts of speed. This form of persistence hunting may have provided access to valuable sources of meat and fat. Even if Homo erectus did not always hunt successfully, the ability to move across large territories increased opportunities for survival during difficult seasons. Movement also shaped how they experienced the world psychologically. Modern humans spend much of life surrounded by permanent structures and predictable environments. Homo erectus likely experienced existence as a continuous relationship with changing landscapes. Rivers shifted, food sources disappeared, storms altered familiar territory. Knowledge of land became essential. Remembering where water could still be found during dry periods, or recognizing safe travel routes, may have meant the difference between survival and starvation. Information stored inside the mind became a survival tool just as important as any stone hand axe. Social cooperation likely grew more important as well. A lone human in prehistoric environments faced overwhelming risks. Injuries, illness, predators, and hunger could quickly become fatal without group support. Living together allowed individuals to share food, defend one another, watch for danger, and care for offspring over long developmental periods. Human children require unusually extended care compared to many animals, and this dependency may have strengthened cooperation within groups over evolutionary time. Scientists cannot know exactly how Homo erectus communicated, but some form of increasingly sophisticated social coordination was almost certainly necessary for survival. Fire may have deepened these social bonds even further. Evidence suggests Homo erectus likely controlled fire, at least in some populations, though exactly when this behavior became widespread remains debated. Even limited fire use would have transformed daily life. Nighttime changed completely in the presence of controlled flames. Darkness no longer forced immediate inactivity. Groups could gather together after sunset in relative safety and warmth. Predators that once dominated the night became less threatening near firelight. Cooked food became easier to chew and digest, allowing humans to extract more usable energy from meals. Some scientists believe cooking may have contributed to long-term biological changes by reducing digestive demands and supporting larger brains over time. Around ancient fires, something else may have developed slowly: extended social attention. Watching flames together creates stillness, It draws focus inward toward nearby faces, gestures, sounds, and shared experiences. While no evidence can fully reconstruct those moments, it is possible that fire changed not only physical survival, but also emotional and social life within human groups. Small habits repeated across thousands of generations can gradually reshape an entire species. What makes Homo erectus especially fascinating is how balanced their survival strategy appears in hindsight. They were neither primitive animals barely surviving nor advanced humans resembling modern civilization. Instead, they occupied a middle space that proved astonishingly stable for over 1 million years. Their technology changed slowly. Their lifestyles remained closely tied to nature, yet they adapted successfully across immense geographic and environmental ranges. In evolutionary terms, stability itself can represent success. Modern humans often assume rapid innovation is always beneficial, but Homo erectus demonstrates another possibility. A species can endure for extraordinary lengths of time without transforming the world dramatically around it. Eventually, though, even Homo erectus would not remain unchanged forever. As populations spread farther across continents and became separated by geography and climate, new variations within the human family continued emerging slowly over hundreds of thousands of years. Some descendants of Homo erectus would adapt to colder northern regions, others would evolve along entirely different paths. The human family tree was continuing to branch outward, preparing the world for an age when many kinds of humans would coexist at the same time. As Homo erectus populations spread across vast distances, something quiet but powerful began happening within the human family. Groups that once shared common ancestors became separated by mountains, deserts, forests, changing climates, and immense stretches of land. Over long enough periods, isolation changes living things. Small differences accumulate generation after generation. Bodies adapt to local environments. Behaviors shift according to survival pressures. Features that once connected distant populations slowly begin diverging. Evolution rarely moves quickly enough for individuals to notice it. Parents still resemble their children. One generation still recognizes the next. But across hundreds of thousands of years, separation can transform a species into many branches. This process likely shaped much of later human diversity. Ancient human populations did not possess maps or understand continents as modern people do. They moved according to food availability, climate shifts, safety, and opportunity. Some groups remained relatively isolated for immense stretches of time. Others encountered neighboring populations occasionally. Geography itself became an invisible force guiding human evolution. A mountain range could separate populations for thousands of generations. Rising seas could isolate island groups. Expanding ice sheets could push humans into unfamiliar territory. Every environmental barrier created conditions where populations might slowly evolve in different directions. Scientists still debate the exact evolutionary relationships among later human species, but many researchers believe Homo erectus stands near the root of several important branches. Over time, descendants of earlier Homo erectus populations likely gave rise to species adapted for very different conditions. In Europe and parts of Western Asia, populations facing long Ice Age climates eventually produced Neanderthals, whose bodies became heavily built and specialized for colder environments. In Asia, other populations evolved along paths scientists are still uncovering through fossils and ancient DNA. Some groups disappeared without leaving clear traces. Others survived long enough to interact directly with Homo sapiens much later. What matters most is that humanity was no longer one evolving population. It had become many experiments unfolding simultaneously across the Earth. This branching pattern challenges one of the oldest misunderstandings about evolution, the idea that evolution works toward perfection. evolution does not aim upward toward a final superior species. It responds only to immediate survival pressures within specific environments. A trait beneficial in one climate may become harmful in another. A body suited for cold northern winters may struggle in tropical heat. Large populations may survive conditions that wipe out smaller isolated groups. Chance matters alongside adaptation. Disease matters. Geography matters. Climate matters. The survival of any human species depended on a fragile combination of factors that no group could fully control. Looking backward from modern times creates the illusion that Homo sapiens was always destined to dominate the planet. But ancient humans living hundreds of thousands of years ago would not have seen history unfolding toward an obvious outcome. To them, survival was local and uncertain. One harsh winter, prolonged drought, volcanic eruption, or failed migration could threaten an entire population. Many human species that once seemed successful eventually disappeared despite surviving for immense stretches of time beforehand. Even Homo erectus, after more than 1 million years of endurance, slowly vanished from the earth. Their disappearance did not happen suddenly. Different populations likely disappeared at different times, across different regions. Some may have contributed genetically to later human groups, others ended completely. Like many extinct human species, they left behind only fragments, bones buried beneath ancient soil, shaped stones worn smooth by time, traces of movement frozen in fossilized footprints. Yet their legacy remained enormous. Homo erectus changed the scale of human existence. They transformed humanity from a localized African lineage into a global evolutionary presence. Because they traveled so widely and survived so long, they created the conditions where many later human species could emerge. Without Homo erectus, the crowded human world that followed may never have existed. The Earth might never have become a place where multiple kinds of humans shared the same age. And this realization changes the emotional weight of human history. Modern people often see themselves as standing at the center of a completed story. But viewed across deep time, Homo sapiens appears less like the inevitable destination of evolution and more like one surviving branch from a once much larger family. A family shaped by separation, adaptation, migration, and extinction. A family where most members are now gone. By the time later human species spread across Europe, Asia, Africa, and isolated islands, the world had become something no modern person has ever experienced again. A planet inhabited not by one humanity, but by many. By the time multiple human species occupied different parts of the Earth, the planet had become a far stranger place than modern people usually imagine. Today, every human face belongs to the same species. Even across enormous cultural and physical differences, there is a shared biological familiarity everywhere on Earth. But during parts of prehistory, that familiarity may have existed alongside visible differences that no modern person has ever encountered directly. Different kinds of humans adapted to different environments, each carrying bodies shaped by thousands of generations of survival under specific conditions. Some lived in freezing regions beneath heavy skies and long winters. Others survived in isolated tropical landscapes, cut off from the wider world. Humanity had diversified into many forms. Among the best known of these ancient humans are Neanderthals. For a long time, Neanderthals were misunderstood as primitive, unintelligent cave dwellers barely capable of survival. Early reconstructions often exaggerated their differences from modern humans, portraying them as hunched and almost animal-like. But scientific understanding has changed dramatically over the last century. Neanderthals are now recognized as highly adapted humans who survived harsh Ice Age environments across Europe and parts of Western Asia for hundreds of thousands of years. Their bodies reveal how deeply evolution responds to climate. Neanderthals were generally shorter and more heavily built than modern humans, with broad chests and strong limbs that helped conserve heat in cold environments. Their noses were larger, possibly assisting with warming cold air before it entered the lungs. They possessed remarkable physical strength, likely necessary for close-range hunting against large Ice Age animals such as bison, deer, and mammoths. Life in glacial climates demanded endurance, coordination, and resilience. Yet Neanderthals were not merely surviving through brute force. Archaeological evidence suggests they crafted sophisticated stone tools, controlled fire, and may have created symbolic objects. Some sites indicate they cared for injured group members who could not survive without assistance. This detail matters deeply because care requires social bonds extending beyond immediate survival value. An injured individual unable to hunt or gather food still remained part of the group. Such evidence slowly changes the emotional image of Neanderthals from strange creatures into recognizable humans living difficult lives under extreme conditions. Farther east, another human population existed that remained almost completely unknown until very recently. In 2010, scientists studying a small finger bone discovered in Siberia identified DNA belonging to a previously unrecognized human group, now called Denisovans. Very few Denisovan fossils have been found, meaning researchers still know surprisingly little about their physical appearance. Yet, their genetic legacy remains inside some modern human populations today, especially among groups in parts of Asia and Oceania. This discovery transformed how scientists understood the ancient world. Entire human populations had existed, interacted with others, and disappeared while leaving behind almost no visible fossil record. Humanity's past turned out to be more hidden and fragmented than researchers once believed. In Southeast Asia, another astonishing discovery challenged assumptions about what human evolution could produce. On the Indonesian island of Flores, scientists uncovered remains belonging to Homo floresiensis, often informally called the Hobbit because of its small body size. Adults stood around 1 meter tall, with unusually small brains compared to modern humans. Yet stone tools found nearby suggested organized behavior and survival skills. Their existence raised difficult questions. How could a human species with such a small brain survive for so long? Researchers believe island isolation may have shaped their evolution through a process known as island dwarfism, where limited resources favor smaller body sizes over time. Still, many mysteries remain unresolved. Homo floresiensis reminds scientists that human evolution did not always move toward larger bodies or bigger brains. Different environments produced different solutions. Together, these discoveries reveal a prehistoric world filled with human diversity far beyond what earlier generations imagined. There was no single model of what a human had to be. Some species became powerful cold-weather hunters. Others adapted to isolated islands. Some disappeared almost entirely from the fossil record, surviving mainly through traces hidden inside modern DNA. The human family was once broad, varied, and deeply shaped by geography, and somewhere within that ancient world of many humans, Homo sapiens had not yet become alone. For a long time, modern humans comforted themselves with a simple belief about the past. Other human species were less capable, less intelligent, and less emotionally complex than we are. This idea placed Homo sapiens safely at the top of human history, separated from every extinct branch below. But the deeper archaeologists explored ancient caves, campsites, tools, and burial grounds. The more difficult that comforting picture became to defend. Evidence kept revealing behaviors that looked unexpectedly familiar, not identical to modern life, but close enough to unsettle old assumptions about what it means to be human. Among Neanderthals, One of the clearest signs of complexity appears in the treatment of injured individuals. Scientists have discovered Neanderthal skeletons showing severe injuries that had healed long before death. Some individuals survived with damaged limbs, partial blindness, or conditions that would have made hunting extremely difficult. In Ice Age environments, survival was already dangerous even for healthy individuals. The fact that injured people remained alive for years suggests that others provided food, protection, and care. This was not simple instinct alone. Long-term care requires patience, cooperation, and social stability within a group. It means individuals mattered beyond their immediate usefulness. In some archaeological sites, researchers also found possible evidence of deliberate burial practices. The interpretation of these findings remains debated in certain cases, but several sites suggest Neanderthals intentionally placed bodies in protected spaces. Whether these actions reflected symbolic thinking, emotional attachment, ritual behavior, or practical concerns is still uncertain. Yet even the possibility changes the emotional landscape of prehistory. Somewhere in cold caves and rocky valleys, ancient humans may have paused beside the dead instead of abandoning them immediately to predators and weather. Another striking feature of Neanderthal life was their technological adaptability. Their stone tools were not random broken rocks but carefully shaped implements designed for specific tasks. Different tools served different purposes: cutting meat, scraping hides, shaping wood, processing plants. Over time, these technologies evolved and varied between regions, suggesting learning traditions passed across generations. Knowledge was being preserved socially. A young Neanderthal likely learned techniques by observing older group members, much like human children learn practical skills today. This transmission of information across generations is one of the foundations of culture. Meanwhile, Denisovans remain far more mysterious because so little fossil evidence survives. Yet the genetic traces they left inside modern populations reveal that they were widespread enough to encounter and interbreed with other human groups. One particularly important Denisovan genetic contribution affects how some modern Tibetan populations survive at high altitudes with low oxygen levels. This suggests Denisovans had already adapted biologically to extreme mountain environments long before Homo sapiens entered those regions. Even without fully knowing their appearance, scientists can see evidence of remarkable environmental specialization encoded within surviving DNA. The story of Homo floresiensis raises different questions entirely. Their small bodies and brains once led some researchers to doubt they represented a separate human species at all. Yet evidence increasingly supports the idea that they survived for long periods on the isolated island of Flores while using stone tools and adapting successfully to local conditions. Island environments often produce unusual evolutionary outcomes because limited resources reshape survival pressures. Large animals may become smaller over generations. Small animals may grow larger in the absence of predators. Homo floresiensis appears to be part of this broader biological pattern. Their existence challenges the assumption that intelligence and survival always require larger brains. Evolution works only well enough for a species to survive within its environment. There is no universal design. What ties all these human species together is not sameness, but adaptability. Each group represents a different solution to survival under different conditions. Ice Age hunters in Europe developed bodies suited for cold climates. Isolated island populations adapted to limited resources. Mountain populations evolved ways to survive thin air. Humanity was once a collection of experiments unfolding across the Earth simultaneously. Some branches became physically stronger, others became smaller. Some may have relied more heavily on cooperation, memory, or environmental knowledge. There was no single correct version of being human. And this realization slowly reshapes the modern understanding of ourselves. Homo sapiens did not emerge into an empty world, waiting to be conquered. We entered a planet already inhabited by other humans who had survived, adapted, and evolved in their own ways over immense stretches of time. They were not failed attempts at humanity. For hundreds of thousands of years, they were humanity too. If someone could stand on a high mountain and look across the prehistoric world tens of thousands of years ago, they would not see a planet ruled by one humanity. They would see scattered populations of different human species living in separate environments, each shaped by the pressures surrounding them. In colder northern lands, groups of Neanderthals moved through forests and open plains beneath long winters. In parts of Asia, populations connected to Denisovans survived across landscapes scientists still only partially understand. On isolated islands, smaller human species adapted to worlds cut off by rising seas and dangerous distances. Across Africa, Homo sapiens populations continued changing as well, carrying their own variations, traditions, and survival strategies. Humanity was divided into branches spread unevenly across the earth, none of them fully aware of the larger picture unfolding around them. This ancient world was not crowded in the modern sense. Human populations remained small, almost everywhere. Entire regions could pass without a single human settlement. Injuries appear frequently in Neanderthal skeletons, suggesting close-range hunting strategies that demanded coordination and courage. A failed hunt could mean starvation. A serious wound could end a life quickly without group support. Yet Neanderthal populations survived across these harsh environments for hundreds of thousands of years. Such long-term survival points toward highly effective adaptation rather than primitive incompetence. Evidence of care within Neanderthal communities deepens this picture further. Some individuals lived for years despite severe injuries or disabilities that would have limited independent survival. One well-known Neanderthal skeleton from Iraq showed signs of blindness and major physical impairment, yet the individual survived long enough for injuries to heal extensively. This suggests sustained care from others within the group. Compassion may be difficult to measure scientifically, but practical care requires social stability, patience, and emotional bonds strong enough to support vulnerable individuals during difficult conditions. These behaviors feel deeply familiar because they remain central to human social life today. Scientists also continue debating evidence of symbolic behavior among extinct human species. Some Neanderthal sites contain pigments, carved objects, eagle talons possibly used as ornaments, and cave markings whose meaning remains uncertain. None of this proves that Neanderthals thought exactly like modern humans, but it suggests their mental world may have been richer than older stereotypes allowed. Symbolic behavior matters because it reflects the ability to attach meaning to objects or actions beyond immediate survival needs. Even small traces of symbolism hint at minds capable of abstraction, memory, and shared social understanding. Meanwhile, discoveries connected to Denisovans continue surprising researchers despite the limited fossil evidence available. Genetic analysis shows they successfully adapted to difficult environments over long periods. One Denisovan-derived gene variant still helps some modern Tibetan populations process low oxygen at high altitudes. This means extinct human species contributed biological solutions to survival that continue influencing modern humans today. The story of intelligence becomes even more complicated when considering Homo floresiensis. Their brains were much smaller than those of modern humans, yet they survived on Flores Island for long periods while using tools and adapting successfully to local conditions. This challenges assumptions that larger brains alone determine behavioral complexity. Evolution rarely follows simple rules. Different environments reward different combinations of traits. The growing body of evidence surrounding these ancient humans slowly transforms the emotional meaning of prehistory. Extinct human species were not empty placeholders waiting for Homo sapiens to arrive. They were populations with social lives, learned knowledge, environmental expertise, and survival strategies refined across immense stretches of time. Some may have thought differently from us in ways impossible to reconstruct completely, yet the more researchers uncover, the harder it becomes to view them as creatures standing outside humanity altogether. They occupy different branches of the same larger family human beings, shaped by worlds far older and harsher than our own. Human survival has never depended on strength alone. Compared to many animals, the human body is physically fragile. We lack claws, thick fur, powerful jaws, or natural weapons capable of defending us easily against large predators. What allowed human species to survive across difficult environments was not raw physical power, but the ability to share knowledge. Information passed from one individual to another became one of the greatest survival tools ever developed. The deeper scientists study extinct human species, the more evidence suggests that many of them also depended heavily on learning, communication, and cultural transmission to survive. Among Neanderthals, tool-making traditions remained stable across generations and regions. This matters because tools do not reproduce biologically like body traits. Every new generation had to learn how to shape stone, recognize useful materials, and apply techniques correctly. Young individuals likely observed older group members repeatedly before mastering these skills themselves. Mistakes would have wasted valuable resources or produced ineffective tools. The consistency seen across many Neanderthal sites suggests teaching, imitation, and memory played important roles within their communities. Knowledge survived because minds carried it forward together. Hunting large animals also required coordination, difficult to achieve without some form of structured communication. Neanderthals hunted dangerous prey in environments where failure carried serious consequences. A group confronting a large animal at close range needed timing, awareness, and cooperation. Even without language identical to modern speech, some organized communication system almost certainly existed. Scientists continue debating how sophisticated Neanderthal language abilities may have been, but evidence increasingly suggests they possessed at least some biological features linked to speech capacity. The exact sounds of their voices remain forever unknown. Yet silence alone could never have supported the complex cooperation their survival demanded. Around ancient fires, communication may have extended beyond immediate survival instructions. Human beings naturally share experiences through gestures, sounds, expressions, and repeated behaviors. Stories in the modern sense may not have existed yet, but memory and social identity likely still mattered deeply. Certain locations may have carried significance because hunts occurred there repeatedly. Certain routes may have been remembered across generations. Certain dangers may have become embedded within collective experience. Culture does not require writing or cities. At its foundation, culture simply means information shared socially and preserved through time. By that definition, many extinct human species likely possessed forms of culture suited to their own lives and environments. Evidence of possible symbolic behavior strengthens this possibility. Archaeologists have uncovered objects associated with Neanderthals that appear modified beyond purely practical needs. Pigments, feathers, eagle talons, and carved items found at some sites suggest that appearance or symbolism may have carried social meaning. Researchers remain cautious because interpreting symbolism from ancient remains is difficult. A colored object does not automatically prove artistic thought in the modern sense, yet repeated patterns across different sites suggest these behaviors were unlikely to be meaningless accidents. Some actions may have reflected group identity, social status, memory, or emotional expression. Even simple symbolism marks a major shift in how minds relate to the world. It means objects can represent ideas extending beyond immediate physical survival. The mystery deepens further with Denisovans because so little direct evidence survives. Despite this, their genetic contributions to modern populations reveal successful long-term adaptation across wide regions. They were not isolated anomalies, but established human populations surviving under demanding environmental conditions. Some researchers suspect Denisovans may have interacted with multiple human groups over long periods, exchanging genes and perhaps behaviors as populations moved and overlapped across Asia. Even now, much of their story remains hidden beneath time and incomplete fossil evidence. The possibility of cultural complexity among ancient humans changes how modern people understand intelligence itself. Intelligence is often imagined as a ladder leading upward toward modern civilization. But prehistoric survival required forms of intelligence many modern people rarely use anymore. Tracking environmental patterns, remembering seasonal changes, recognizing animal behavior, navigating landscapes without maps, cooperating closely within small groups, and adapting constantly to uncertainty. Different human species may have excelled at different forms of survival knowledge shaped by their environments. There was never one universal model of intelligence. This realization softens the old divide between Homo sapiens and the extinct humans who once shared the earth with us. They were not unfinished versions of modern people waiting for civilization to arrive. They carried their own learned traditions, survival strategies, social relationships, and ways of understanding the world around them. Much of that knowledge vanished when they disappeared. Only fragments remain, now shaped stones, traces of pigment, buried bones, scattered DNA. Yet those fragments continue, revealing something increasingly difficult to ignore. Humanity's lost relatives may have been far more mentally and socially complex than our species once wanted to believe. The more scientists learned about extinct human species, the more uncomfortable a certain question became. If other humans could survive harsh climates, care for one another, create tools, share knowledge, adapt across generations, and perhaps even express symbolic behavior, then what exactly made Homo sapiens different? For a long time, modern people searched for a single trait that separated us cleanly from every other human species. Language was proposed, then tool-making, then art, then intelligence itself. But again and again, discoveries blurred these boundaries. Other human species displayed at least partial versions of many behaviors once considered uniquely ours. The dividing line never stayed as clear as people expected. This does not mean Homo sapiens and extinct human species were identical. Important differences certainly existed, but the deeper the evidence accumulated, the more those differences appeared gradual rather than absolute. Evolution rarely creates sharp categories. Instead, traits emerge slowly, overlap across populations, and vary between groups over time. Humanity was not divided neatly into fully human and not human. It was composed of related species carrying different combinations of abilities, shaped by different evolutionary pressures. One possibility scientists explore involves social scale. Homo sapiens may have become especially skilled at maintaining larger and more flexible social networks than some other human species. Many animals cooperate within small groups, but humans developed unusually complex forms of collective behavior. Individuals could exchange information beyond immediate family connections. Knowledge traveled between groups. Alliances formed across larger territories. Shared symbols and communication systems may have allowed cooperation among people who were not personally familiar with one another. This ability would have created major survival advantages during environmental instability. Information about food sources, migration routes, dangers, or seasonal changes could spread more widely through interconnected populations. Another important possibility involves adaptability itself. Some extinct human species became highly specialized for certain environments. Neanderthals, for example, were exceptionally well adapted to cold Ice Age climates. Their bodies conserved heat efficiently and supported physically demanding hunting strategies. Yet specialization can carry risks. A species deeply adapted to one environmental condition may struggle when conditions shift rapidly. Homo sapiens, by contrast, may have possessed greater behavioral flexibility. Instead of relying primarily on physical adaptation, our species increasingly altered behavior, technology, and social organization in response to changing environments. Clothing, shelters, expanded trade networks, and more varied diets may have helped Homo sapiens survive across a wider range of conditions. Population size may also have mattered enormously. Small, isolated populations face constant danger from disease, environmental disasters, food shortages, and loss of genetic diversity. Even highly capable human species can disappear if their numbers fall too low for too long. Larger interconnected populations are generally more resilient because knowledge, resources, and genetic variation circulate more widely. Some researchers believe Homo sapiens gradually expanded population networks in ways that reduced extinction risks compared to smaller fragmented groups. Yet none of these explanations fully solve the mystery. Intelligence alone does not guarantee survival. Neither does strength, adaptability, or cooperation by itself. Extinction often emerges from combinations of pressures rather than one simple cause. Climate fluctuations reshaped habitats repeatedly. Volcanic eruptions may have disrupted ecosystems. Competition over territory and food likely intensified in some regions. Interbreeding blurred boundaries between groups. Disease may have spread during contact between populations. Chance itself always remained part of evolution. A severe winter striking one vulnerable population at the wrong moment could alter the future permanently. What makes this question emotionally difficult is that Homo sapiens did not necessarily survive because we were morally better, wiser, or destined to rule the earth. Evolution does not reward virtue. It does not move toward fairness or meaning. It preserves whatever survives long enough to reproduce under changing conditions. Many extinct human species were successful for immense stretches of time before eventually disappearing. Some survived far longer than human civilizations have existed today. Looking backward now, it is tempting to imagine our survival as inevitable because we are the ones still here to tell the story, but prehistory offers no evidence that the outcome was guaranteed. There may have been moments when Homo sapiens itself stood dangerously close to disappearance. The ancient world contained many human possibilities unfolding simultaneously. Most eventually vanished, one remained. And perhaps the strangest part of all is this. Even after every other human species disappeared, traces of them never fully left. Pieces of their biology continue living quietly inside modern humans today. The boundary between us and them was never as complete as it first appeared. For most of modern human history, no one realized that our ancestors once shared the earth with other human species. The idea seemed almost impossible. Humanity felt singular, isolated, complete. But tens of thousands of years ago, long before cities or written language, Homo sapiens moved into regions where other humans were already living. This may be one of the strangest moments in the entire history of life on Earth. Different kinds of humans encountering one another beneath the same sky. Not different cultures within one species, but separate human lineages shaped by hundreds of thousands of years of partially independent evolution. Somewhere in ancient valleys, forests, mountains, and coastlines, these meetings truly happened. The most well-known encounters likely occurred between Homo sapiens and Neanderthals. By the time modern humans expanded out of Africa in significant numbers, Neanderthals had already survived across Europe and parts of Western Asia for hundreds of thousands of years. They understood those environments deeply. They knew migration routes, seasonal changes, dangerous terrain, and the behavior of local animals. Homo sapiens arriving from Africa were entering landscapes already occupied by another successful human species. For a period of time lasting several thousand years, these populations coexisted in overlapping regions. Scientists still debate exactly how often they interacted and under what circumstances. Some encounters may have been cautious and distant. Others may have turned violent over territory or resources. Some may have involved trade, observation, imitation, or even cooperation during difficult conditions. Ancient bones and tools cannot fully reconstruct the emotional reality of those meetings. Yet one fact is now undeniable. The two groups did not remain completely separate. Modern genetic evidence has transformed our understanding of these encounters. Most people living outside Africa today carry small percentages of Neanderthal DNA inherited from ancient interbreeding events between Homo sapiens and Neanderthals. This means that somewhere in the distant past, individuals from these populations formed intimate enough relationships to produce children whose descendants survived into the present. The implications feel almost difficult to absorb emotionally. Another human species did not simply disappear into abstraction. Their biological traces continue living inside billions of people today. The boundaries between ancient human species were more permeable than earlier generations imagined. The same pattern appears with Denisovans. Genetic studies show that Homo sapiens also interbred with Denisovan populations in parts of Asia. Some modern populations, especially in Oceania and parts of Southeast Asia, inherited measurable Denisovan ancestry. Again, this means direct encounters occurred between different human species. Entire chapters of human interaction unfolded without written records, leaving behind only scattered fossils and fragments of DNA as evidence. These discoveries transformed the ancient world from a story of isolated species into one of overlapping populations connected through migration, coexistence, and exchange. Yet coexistence likely carried tension as well. Different human species competing for similar food sources and territories would inevitably affect one another. Ice Age environments often provided limited resources, especially during harsh climatic shifts. Large hunting animals migrated unpredictably. Winters could become severe. A growing Homo sapiens population entering territories already occupied by Neanderthals may have intensified pressure on vulnerable groups. Even indirect competition can reshape survival. One species developing more flexible hunting strategies, broader trade networks, or larger population structures may gradually outcompete another without open conflict occurring constantly. What makes these encounters so emotionally powerful is the realization that ancient humans may have looked into faces both familiar and strange at the same time. A Neanderthal child laughing beside a fire may not have seemed entirely alien to a Homo sapiens observer. Gestures, emotions, fear, curiosity, care for family, many behaviors may have felt recognizable across species boundaries, yet differences would also have existed. Body structure, movement, voices, facial features, and perhaps ways of thinking may all have carried subtle signals of separation. No modern experience truly parallels this. Humanity today has forgotten what it feels like to coexist with another form of human life. The ancient world still remembered. For a brief window in deep history, the Earth contained multiple human species aware of one another's presence. Some exchanged genes, some competed, some disappeared, and none of them could fully know that only one branch of humanity would eventually remain to remember the others. No living human today has experienced what ancient Homo sapiens once experienced, seeing another human species with their own eyes. Modern people encounter differences in language, culture, appearance, and behavior, but every person alive still belongs to the same biological species. Prehistoric humans lived in a stranger reality. At certain moments in deep history, a human could look across a valley or through the flickering light of a distant fire and see another kind of human moving through the world. Not an animal, not entirely unfamiliar, but not fully the same either. Trying to imagine the emotional weight of such encounters is difficult because modern experience offers almost no comparison. A meeting between Homo sapiens and Neanderthals may have carried layers of recognition and uncertainty at the same time. Neanderthals walked upright, used tools, controlled fire, hunted cooperatively, and cared for members of their groups. They expressed emotion through posture, voice, movement, and facial expression just as modern humans do. A frightened Neanderthal child likely sounded frightened. An injured adult likely showed pain in recognizable ways. Some gestures of warning, curiosity, or aggression may have been immediately understandable across species boundaries. Yet, important differences almost certainly existed too. Neanderthals were generally more heavily built than Homo sapiens, with broad chests, powerful limbs, and distinctive facial features shaped partly by long adaptation to cold climates. Their voices may have sounded different. Their rhythms of communication may not have matched ours perfectly. The human brain evolved through social recognition, constantly separating familiar individuals from potential threats. Encountering another human species may have activated both instincts at once, recognition and caution. Scientists can study bones, tools, and DNA, but they cannot fully reconstruct the psychological experience of these meetings. Some encounters may have been peaceful and brief. A small group notices distant figures near a river, watches cautiously, and moves away. Other meetings may have become violent when food, territory, or survival pressures intensified. Ice Age environments often offered limited resources, especially during harsh winters or climate instability. Competition between populations does not require hatred to become dangerous. Sometimes, survival alone creates conflict. Even indirect competition matters. A species with larger social networks, more flexible diets, or faster population growth can gradually displace another over long periods without open warfare dominating every interaction. Yet the evidence of interbreeding shows that not all contact ended in hostility. Homo sapiens and Neanderthals formed relationships intimate enough to produce children. This means moments of trust, attraction, or social integration occurred at least occasionally between populations separated by hundreds of thousands of years of evolution. Those children inherited biology from both lineages. Some survived and passed their genes forward generation after generation until traces still remained inside humans alive today. This complicates any attempt to divide ancient humanity into simple categories of us and them. The boundaries were never completely closed. Encounters with Denisovans likely carried similar complexity, though much less is known about them directly. Their physical appearance remains largely mysterious because fossil evidence is scarce. Yet genetic traces reveal repeated contact with Homo sapiens populations across Asia. Some ancient humans moved through landscapes where several human groups may have overlapped over time. The prehistoric world was not static. Populations migrated, expanded, disappeared, and encountered one another repeatedly as climates shifted and environments changed. There is also something deeply unsettling hidden inside these encounters. For most of human existence today, Homo sapiens has lived with the quiet assumption that humanity belongs entirely to us. But ancient humans lived closer to a reality where humanity itself was shared territory. Another species could make tools, survive harsh winters, bury the dead, and perhaps communicate in ways partially understandable. Another species could watch the same storms approach and feel fear. Another species could look back at Homo sapiens with its own mixture of recognition and uncertainty. This ancient coexistence may have shaped human psychology more deeply than modern people realize. The instinct to distinguish familiar groups from outsiders, the tension between curiosity and caution, the ability to cooperate while competing, all may have roots extending far into a world where different human species once occupied overlapping landscapes. And while these encounters unfolded across thousands of years, the balance was already beginning to shift slowly. Homo sapiens populations continued spreading. Other human species gradually became fewer. The crowded human world that had existed for so long was beginning to narrow toward a future where only one branch would remain visible. For thousands of years, different human species continued sharing parts of the Earth together. Their territories shifted with climate changes, migrations, and population pressures. Some regions may have seen only brief overlap between groups. Other regions likely experienced repeated contact across many generations. Yet over time, something irreversible began happening. The ancient world that once contained multiple human species slowly started losing them one by one. The process was gradual enough that no individual living through it could fully understand what was occurring. Entire generations were born into worlds where other humans still existed, then died before realizing those populations were becoming smaller and more fragile. The disappearance of ancient human species did not happen all at once. Different populations faded at different times across different landscapes. Neanderthals survived in parts of Europe and Western Asia until roughly 40,000 years ago, though exact dates remain debated. By then, Homo sapiens populations had already expanded widely into many of the same regions. Climate instability intensified during this period, repeatedly reshaping environments and food availability. Forests expanded and contracted, ice sheets altered migration routes, large animal populations shifted unpredictably. Human groups already living close to survival limits faced increasing pressure. Small populations are especially vulnerable during unstable periods. A few difficult winters, food shortages, diseases, or failed migrations can reduce numbers rapidly. Once populations become too small, recovery grows increasingly difficult. Genetic diversity declines. Social networks weaken. Knowledge may disappear when skilled individuals die without passing on experience successfully. Isolation itself becomes dangerous. Many researchers believe Neanderthal populations were already relatively small and fragmented before Homo sapiens fully expanded into their territories. Under such conditions, even indirect competition could have major consequences. Homo sapiens may not have needed to destroy Neanderthals through constant violent conflict for Neanderthal populations to decline gradually over time. Slight differences in adaptability, social networking, population growth, or resource use could slowly shift survival odds generation after generation. Some scientists propose that Homo sapiens possessed broader trade connections or more flexible diets that helped populations remain resilient during environmental change. Others emphasize the role of larger social networks capable of sharing information across wider territories. A hunting technique discovered in one region could potentially spread farther within Homo sapiens populations. Environmental knowledge may have circulated more efficiently, yet no explanation fully accounts for the disappearance of every other human species. Evolution rarely provides simple answers. Interbreeding also complicated the process. Ancient DNA shows that Neanderthals did not vanish completely without trace. Some populations merged partly into expanding Homo sapiens groups through repeated mixing over time. This means extinction was not always a clean ending, where one species disappeared and another remained untouched. Sometimes human populations blended together biologically before one lineage gradually lost its separate identity. The same pattern likely occurred with Denisovans in parts of Asia. Pieces of these ancient humans survive inside modern populations, even though the original groups themselves no longer exist independently. This creates an unusual form of survival through absorption rather than total disappearance. There is also a quieter possibility that receives less attention: chance. Modern humans often search for grand explanations because the survival of Homo sapiens feels enormously important in hindsight. But evolution does not operate according to destiny. Small accidents can reshape history permanently: a volcanic eruption affecting migration routes, a disease spreading unevenly between populations, a series of harsh winters striking vulnerable groups repeatedly. Tiny advantages or disadvantages accumulated over centuries may eventually determine which populations survive. Looking backward from the present creates the illusion that Homo sapiens was always meant to become the final human species, but the ancient world would not have looked that way to the humans living inside it. To them, survival remained uncertain every season. What makes this transformation emotionally haunting is how quiet it likely appeared while it happened. No one announced the end of the Neanderthals. No one recorded the last Denisovan community. There was no final meeting where humanity consciously realized it was becoming alone. One group disappears from a valley. Another population shrinks beyond recovery. Children are born into landscapes where certain human voices are no longer heard. Gradually, the crowded human world becomes emptier, and eventually, without fully understanding how or why, Homo sapiens found itself standing as the only surviving human species left on Earth. One of the largest questions in human history still does not have a complete answer. Why did every other human species disappear while Homo sapiens survived? Scientists have studied this question for decades through fossils, climate records, ancient DNA, archaeology, and evolutionary biology. Yet, the deeper the evidence becomes, the less likely a simple explanation appears. There was probably no single moment when one human species suddenly defeated all the others. No final battle decided the future of humanity. Instead, extinction likely emerged slowly from many pressures overlapping across enormous stretches of time. Climate, geography, population size, disease, migration, adaptability, and chance all interacted in ways no ancient human could fully control. Climate change may have been one of the most important pressures. During the late Ice Age, environments shifted repeatedly over thousands of years. Forests expanded and contracted. Grasslands dried or disappeared. Animal migration patterns changed. Temperatures fluctuated in ways that altered food availability across entire regions. Human species already specialized for certain environments suddenly faced unstable conditions. Neanderthals, for example, had spent hundreds of thousands of years adapting successfully to cold Eurasian climates. Their bodies, hunting strategies, and lifestyles fit those environments remarkably well. But specialization can become dangerous when environments begin changing rapidly. A species highly adapted to one ecological condition may struggle to adjust quickly enough when familiar landscapes transform. Homo sapiens may have held an advantage in behavioral flexibility rather than physical specialization. Evidence suggests our species adapted to a wide range of habitats relatively quickly. Homo sapiens populations survived in deserts, tropical regions, coastlines, forests, and colder climates using changing combinations of tools, clothing, shelters, and social strategies. Instead of depending primarily on biological adaptation over long evolutionary periods, modern humans increasingly responded behaviorally. This flexibility may have allowed Homo sapiens populations to endure environmental instability more effectively than some other human species. But adaptability alone does not fully explain survival. Population structure likely mattered as well. Small, isolated populations face constant extinction risks. A disease outbreak, severe winter, failed hunting season, or environmental disaster can reduce numbers below sustainable levels very quickly. Once populations become too fragmented, recovery becomes increasingly difficult. Genetic diversity declines, increasing vulnerability further. Some researchers believe Neanderthal populations may already have been relatively small and scattered before Homo sapiens spread widely into their territories. Under those conditions, even minor disadvantages could slowly accumulate generation after generation. Homo sapiens populations may have maintained larger social networks connecting distant groups. Information, resources, and genetic diversity could circulate more widely within these expanding networks. A successful hunting technique, new tool style, or environmental adaptation discovered in one region may have spread farther among Homo sapiens communities. Larger interconnected populations also recover more easily after local disasters because neighboring groups remain available for support, migration, and reproduction. Disease may have played a role too, though evidence remains difficult to confirm directly. Whenever populations separated for long periods encounter one another again, exposure to unfamiliar pathogens can become dangerous. Throughout later human history, diseases repeatedly reshaped contact between isolated populations. It is possible that similar biological pressures affected interactions between ancient human species, though scientists remain cautious because direct proof is limited. Interbreeding complicates the story further. Ancient DNA demonstrates that extinct human species did not disappear completely in every sense. Neanderthal and Denisovan genes still survive inside modern populations today. This means some ancient human groups were partly absorbed into expanding Homo sapiens populations over time. Extinction, therefore, was not always total replacement. In some cases, ancient humans continued biologically through mixing rather than surviving as separate species. Yet even after accounting for all these factors, uncertainty remains. Evolution does not guarantee fairness, intelligence, or permanence. A species can survive for hundreds of thousands of years and still disappear. Homo sapiens itself may have approached extinction at several points during prehistory. Genetic evidence suggests human populations may once have dropped surprisingly low. If circumstances had shifted slightly differently, another climate event, another migration failure, another disease outbreak, modern humans might also have vanished, while another branch survived instead. Looking backward now creates the illusion that Homo sapiens was destined to inherit the Earth, but history, viewed from inside uncertainty, never feels inevitable. Ancient humans could not see the future. They hunted, traveled, cared for children, survived winters, and adapted as conditions changed around them. They did not know they belonged to species that would one day disappear entirely. And perhaps the hardest truth hidden inside this story is that survival alone does not necessarily prove superiority. It may only prove that one fragile branch managed to endure while the others slowly faded into silence. One possible advantage Homo sapiens may have carried was not greater strength, larger bodies, or even dramatically higher intelligence by itself. It may have been something quieter and less visible at first glance, the ability to maintain large social connections across wider groups of people. Human survival has always depended heavily on cooperation, but Homo sapiens appears to have pushed this ability further than any other known human species. Over time, small improvements in communication, trust, shared memory, and collective organization may have changed the balance of survival across entire regions. Early human groups were usually small, resources were limited, and survival required constant movement through difficult environments. Yet even small groups rarely existed in total isolation forever. Evidence suggests Homo sapiens populations exchanged tools, materials, and information across surprisingly long distances. Certain stone materials found at archaeological sites originated far from where they were eventually used, implying movement, trade, or repeated contact between communities. These exchanges mattered because isolated populations are fragile. Groups connected through broader networks can share resources during shortages, exchange mates to preserve genetic diversity, and spread knowledge more efficiently across landscapes. Knowledge itself became a form of survival technology. Imagine two human populations facing sudden climate change. One group possesses only the experience of its immediate territory. Another receives information through broader social connections, where animals migrated recently, which plants remain edible during droughts, which rivers still carry water, or which territories have become dangerous. Over generations, the second population may respond more flexibly to environmental instability simply because information travels farther. Some researchers believe Homo sapiens developed unusually effective systems of collective learning and memory compared to other human species. This does not necessarily mean individuals were smarter in every measurable way. Instead, it may mean groups became better at preserving and distributing knowledge across time and space. Language likely played a major role, though scientists still debate exactly when modern language fully emerged. Complex speech allows humans to communicate not only immediate dangers, but also abstract ideas, plans, stories, and experiences removed from the present moment. A person can warn others about a predator no longer visible, describe a distant water source, or teach techniques learned years earlier. Information no longer remains trapped inside direct experience. It becomes transferable across generations. Even small increases in communication efficiency can produce enormous long-term survival advantages. Around fires, within migrating groups, and across repeated social gatherings, Homo sapiens may have gradually built networks of shared understanding larger than those maintained by some extinct human species. Another important possibility involves symbolic thinking and shared identity. Humans cooperate more easily when individuals feel connected to something larger than immediate family relationships. Symbols, traditions, rituals, body decoration, and shared stories can strengthen group cohesion among people who do not know one another personally. Archaeological evidence suggests Homo sapiens engaged increasingly in symbolic behavior through ornaments, pigments, carvings, and eventually cave art. The meaning behind these objects remains partly hidden from modern researchers, yet symbolism itself may have helped larger social systems form. Shared identity allows our cooperation beyond small kin groups. It creates trust among strangers connected through common beliefs or cultural practices. This may have given Homo sapiens unusual flexibility when populations expanded into new territories. Meanwhile, some extinct human species, such as Neanderthals, may have relied more heavily on smaller, tightly bonded groups adapted to local environments. Such systems can remain extremely effective under stable conditions, especially when populations know their territories deeply. But during periods of rapid environmental change, broader social networks may provide greater resilience. A group facing food shortages can potentially relocate toward allied populations or exchange information more widely. Over thousands of years, these differences may slowly influence which populations expand and which become increasingly vulnerable. Yet, even here, certainty remains impossible. Scientists cannot directly observe ancient conversations, emotional bonds, or social structures. Much of human prehistory survives only through fragments. Bones, tools, pigments, and genetic traces reveal pieces of the story but not complete lives. It is entirely possible that extinct human species possessed rich forms of communication and culture that archaeology can barely detect today. The survival of Homo sapiens may have depended on combinations of advantages too subtle to isolate individually. What matters is that survival appears increasingly connected not merely to intelligence inside individual minds, but to the ability of many minds to cooperate, remember, and adapt together across generations. Humanity's greatest strength may never have belonged to a single person alone. It may have emerged from networks of shared memory stretching across communities, landscapes, and time itself. And slowly, as these networks expanded, the world of many human species continued narrowing toward a future where only one human lineage remained visible on Earth. Modern humans often search for meaningful explanations behind survival. We prefer to believe that the species still alive today must have earned its place through clear superiority, greater intelligence, stronger cooperation, better morality, or some uniquely advanced trait. Yet evolution rarely follows stories that clean and satisfying. When scientists examine the disappearance of other human species closely, one uncomfortable possibility remains impossible to ignore. Luck may have mattered far more than people want to admit. Survival in the natural world is fragile. Small events repeated across long periods can reshape the future permanently. A drought lasting several years longer than usual, a migration route blocked by changing climate, a disease spreading through one vulnerable population but not another, a volcanic eruption altering ecosystems across entire regions. None of these events carries meaning or intention, yet together they can decide which species continue and which disappear forever. Throughout prehistory, human populations remained relatively small compared to modern societies. Even successful groups often lived close to survival limits. Food shortages, injuries, harsh winters, and environmental instability constantly threatened communities. Under such conditions, chance becomes powerful. A population reduced too far may never recover fully, even if conditions improve later. Genetic diversity declines, social knowledge disappears when experienced individuals die. Children grow up without learning survival strategies once preserved across generations. Extinction does not always require dramatic catastrophe. Sometimes it emerges slowly through accumulated vulnerability. This may have happened to Neanderthals and other extinct human species. By the time Homo sapiens spread widely into Eurasia, some Neanderthal populations may already have been fragmented and declining due to climate instability and low population density. If so, Homo sapiens did not necessarily replace a powerful, thriving species at its peak. Instead, our ancestors may have encountered populations already struggling against environmental pressures beyond their control. Slight differences in flexibility, social networking, or population resilience may then have pushed survival odds gradually in one direction over thousands of years. Yet even Homo sapiens may have approached extinction at certain moments. Genetic studies suggest modern human populations may once have fallen surprisingly low, perhaps only several thousand breeding individuals surviving at some points in prehistory. This means our own species was never guaranteed success. If a few environmental conditions had shifted differently, Homo sapiens itself might have vanished, while another branch of humanity survived instead. The world today would then belong to descendants of a different human species, asking questions about us. This realization changes the emotional meaning of human history. Survival begins to look less like proof of destiny and more like the outcome of countless unstable moments balanced near collapse. Another difficult truth is that evolution has no final goal. It does not move steadily toward perfection. Species survive only as long as they remain compatible with changing environments. Many extinct human species were extraordinarily successful by evolutionary standards. Homo erectus survived for more than 1 million years, far longer than Homo sapiens has existed so far. Neanderthals endured Ice Age Europe for hundreds of thousands of years under conditions most modern humans would find almost unimaginable. Their extinction does not erase their success. Evolution simply never promises permanence. Every species alive today exists inside temporary conditions that may someday change again. There is also a quieter emotional consequence hidden beneath this story. Modern humans often imagine themselves standing apart from nature, controlling the world through technology and civilization. Yet deep history tells a different story. Homo sapiens survived partly because ancient humans remained embedded within environmental systems they could never fully control. Climate shifts, geography, disease, population size, and random events shaped human destiny long before written history began. Even today, modern civilization remains more fragile than it often appears. The disappearance of other human species serves as a reminder that survival itself is never guaranteed forever. Looking back across prehistory, the world once contained many human possibilities. Different species adapted to mountains, islands, forests, frozen plains, and shifting grasslands. Some possessed immense physical resilience. Others carried genetic adaptations modern humans still benefit from today. Some may have thought about the world in ways now permanently lost. Most eventually disappeared quietly, leaving behind fragments buried beneath earth and stone. Homo sapiens became the final surviving branch, not because evolution declared us perfect, but because one fragile lineage managed to continue while the others slowly faded away. And perhaps the strangest part is this: if survival depended partly on chance, then humanity's entire modern world may rest upon a chain of accidents stretching back tens of thousands of years into a past that could easily have unfolded differently. At some point in prehistory, without anyone realizing it, the Earth changed into something entirely new. For millions of years, multiple human species had existed across different regions of the planet. Some survived in cold northern climates, others adapted to forests, islands, mountains, or dry grasslands. Humanity was once diverse not only culturally, but biologically. Then gradually, one by one, the other branches disappeared. The fires of Neanderthal camps went dark. Denisovan populations faded from landscapes now mostly lost to time. Isolated human species vanished from islands and valleys. Eventually, Homo sapiens remained alone. No ceremony marked this transition. No ancient person stood beneath the sky, understanding that the age of many humans had ended forever. Yet sometime after the last surviving populations of other human species disappeared, Homo sapiens became the only human species left on Earth. This loneliness changed the future of humanity in ways still difficult to fully understand. For the first time in millions of years, every human face belonged to the same species. The world no longer contained another kind of human, observing the same storms, hunting the same animals, or walking across neighboring landscapes. One branch of the human family tree had survived, while all the others had become memory buried beneath stone and sediment. At first, this may not have felt important to the humans living through it. Early Homo sapiens still faced the same daily struggles: finding food, surviving weather, protecting children, avoiding injury, and adapting to changing environments. But slowly, over thousands of years, something fundamental shifted. Human culture no longer evolved alongside other human species. Every future civilization, language, belief system, empire, religion, and technological achievement would emerge from one surviving lineage alone. The entire modern world would eventually be shaped by the perceptions and instincts of Homo sapiens, without biological competition from another humanity. Some scientists believe this isolation may have influenced how modern humans think about themselves. Because no other human species survived into recorded history, people gradually came to see humanity as singular and separate from the rest of nature. Ancient myths and religions across many cultures often place humans in a unique category distinct from animals. Perhaps this separation feels natural, partly because Homo sapiens has lived alone for so long that the memory of coexistence disappeared entirely. No modern society inherited living experience of another human species sharing the world beside us. The ancient reality of multiple humanities faded beyond memory long before writing began, yet traces of those lost humans remained hidden inside us. Genetic studies now show that many modern populations still carry small percentages of Neanderthals or Denisovans ancestry. Ancient interbreeding events left biological echoes surviving tens of thousands of years later. Some inherited genes affect immune systems, skin adaptation, metabolism, or high-altitude survival. In this sense, extinct human species never vanished completely. Small parts of them continue living quietly within modern bodies around the world. Humanity did not emerge from the past untouched. We carry fragments of older human worlds inside us even now. The disappearance of other human species also changed humanity's ecological role. Earlier human species had remained limited in population size and technological complexity for immense stretches of time. Homo sapiens eventually became different. Once alone, our species continued expanding across nearly every environment on Earth. Humans crossed oceans, entered remote islands, adapted to deserts, forests, mountains, and Arctic regions. Population numbers grew steadily. Technologies accumulated generation after generation, instead of remaining relatively stable for hundreds of thousands of years. Agriculture, cities, writing, trade networks, and industrial civilization all emerged from the only surviving human lineage. The pace of change accelerated dramatically compared to most earlier human history. Yet this transformation carries a strange contradiction. Modern civilization often creates the illusion that Homo sapiens stands far above every extinct human species that came before. But deep history suggests something more complicated. The world we inherited was not built by one inevitable, perfect species rising alone from primitive origins. It emerged from a vast family of human experiments shaped by climate, migration, adaptation, cooperation, and chance. Most branches disappeared. One survived long enough to reshape the planet itself. And perhaps the loneliness of modern humanity hides an uncomfortable truth. For almost all of human evolutionary history, being human never meant being alone. Once Homo sapiens became the only surviving human species, the relationship between humans and the Earth began changing in ways that had never happened before. Earlier human species had certainly shaped their environments to some extent. They hunted animals, used fire, built temporary shelters, and altered local ecosystems through daily survival activities. But for immense stretches of prehistory, human populations remained relatively small and technologically limited. Environmental change usually happened slowly, driven mostly by climate cycles, volcanic activity, shifting oceans, and other natural forces beyond human control. After the disappearance of other human species, Homo sapiens gradually became something different, a single human lineage capable of spreading across nearly every environment on the planet, while increasingly reshaping those environments in return. The expansion happened slowly at first. Small groups migrated into new territories generation after generation. Humans crossed mountain ranges, followed coastlines, entered dense forests, survived deserts, and eventually reached remote islands separated by dangerous waters. Wherever Homo sapiens arrived, adaptation followed. Clothing changed according to climate. Hunting strategies shifted depending on local animals. Shelters became more specialized. Knowledge accumulated across generations, instead of disappearing entirely when groups moved or environments changed. This growing ability to preserve and transfer information gave Homo sapiens unusual long-term flexibility. Yet expansion also carried consequences for the natural world around them. Scientists continue debating the exact role humans played in prehistoric extinctions, but in several regions, the arrival of Homo sapiens roughly overlaps with the disappearance of large animal species. Giant ground sloths in the Americas, woolly mammoths in parts of Eurasia, enormous flightless birds on islands, and many other large animals vanished during periods connected to environmental change and expanding human populations. Climate shifts clearly contributed in many cases, but human hunting pressure may also have mattered, especially for species already vulnerable to changing ecosystems. This pattern would repeat throughout later history. Human adaptability often increased faster than ecosystems could adjust to human expansion. Fire became one of the most important tools in this transformation. Earlier human species likely used fire as well, but Homo sapiens appears to have expanded its use dramatically across different landscapes. Fire provided warmth, protection, cooking, and light, yet humans also began using controlled burning to shape environments. Intentionally, burning grasslands could encourage the growth of useful plants or attract grazing animals. Forests could be altered to make movement easier. Over time, humans became not just inhabitants of ecosystems, but active modifiers of them. The boundary between natural landscapes and human influence slowly began dissolving. Much later, another enormous transformation emerged: agriculture. For most of human existence, people lived as hunters and gatherers, moving through environments according to seasonal changes and resource availability. Agriculture changed this relationship fundamentally. Humans began staying in one place longer, cultivating plants, domesticating animals, storing food, and building permanent settlements. Population growth accelerated. Villages became towns. Towns became cities. Complex societies formed around systems of agriculture, trade, labor, and political organization. None of this happened suddenly. It unfolded gradually across thousands of years in different parts of the world. Yet once it began, human influence on the planet expanded far beyond anything earlier human species had achieved. The Earth that Homo sapiens inherited from prehistory slowly transformed into a human-shaped world. Forests were cleared, rivers redirected, animals domesticated, landscapes reorganized around human needs. Eventually, industrial civilization amplified this process to a scale ancient humans could never have imagined. Machines extracted resources faster than natural systems could replenish them. Fossil fuels powered massive cities and global transportation networks. Human activity began altering the climate itself. The descendants of small prehistoric groups, surviving uncertain Ice Age landscapes, had become a planetary force capable of reshaping ecosystems across the globe. Yet hidden beneath modern civilization remains a strange irony. Homo sapiens became extraordinarily successful after every other human species disappeared, but that success also created new forms of fragility. Earlier, human species often lived more directly within environmental limits because they lacked the power to escape them temporarily through technology. Modern humans sometimes forget those limits still exist. The disappearance of other human species serves as a reminder that survival is never permanent, even for adaptable and intelligent populations. Deep history shows that humanity once consisted of many branches, shaped by environments they could not fully control. Today, Homo sapiens stands alone, more powerful than any earlier human species ever became. Yet we remain part of the same fragile evolutionary story that shaped every human species before us. Modern humans often describe history as a story of progress. Technology improves, cities grow larger, medicine extends life, information travels instantly across the planet. From this perspective, Homo sapiens appears to stand at the peak of a long upward journey, beginning with primitive ancestors and ending in advanced civilization. Yet deep human history suggests a more complicated picture. Evolution does not measure success according to comfort, morality, intelligence, or technological achievement. It measures only survival and reproduction under changing conditions. By that standard, many extinct human species were extraordinarily successful long before modern civilization existed. Homo erectus survived for over 1 million years while living without agriculture, industry, or permanent cities. Neanderthals endured harsh Ice Age climates for hundreds of thousands of years, using tools, cooperation, and environmental knowledge adapted to their world. Their lives were difficult, but difficulty alone does not equal failure. This creates an uncomfortable question for modern humans. Does technological power automatically mean Homo sapiens represents a better form of humanity? Or does it simply mean our species followed one particular evolutionary path that happened to survive long enough to reshape the planet? The answer may depend partly on how people define progress itself. Modern civilization brought extraordinary achievements: scientific understanding, medicine, art, engineering, communication, and the ability to reduce many forms of suffering that dominated prehistoric life. Yet these advances also created new vulnerabilities unknown to earlier humans. Industrial systems depend on complex global networks vulnerable to disruption. Environmental damage now occurs at planetary scales. Climate change, driven partly by human activity, threatens ecosystems worldwide. Psychological stress, social isolation, and large-scale warfare emerged within civilizations, far more technologically advanced than anything ancient humans experienced. Progress solved some problems while creating others entirely new. Earlier human species lived within environmental limits they could not easily escape. Their populations remained relatively small because food, climate, disease, and geography imposed strict boundaries on growth. Homo sapiens gradually learned how to push against many of those boundaries through agriculture, technology, and social organization. Yet the deeper truth of evolution never disappeared. Humans remain biological organisms dependent on stable ecosystems, clean water, predictable climates, and cooperation with one another. Civilization sometimes creates the illusion that humanity stands outside nature, but deep history repeatedly warns against that belief. Every extinct human species once survived successfully too, until conditions changed beyond what their adaptations could support. There is also a psychological shift hidden inside the story of modern human success. Once Homo sapiens became the only surviving human species, humans no longer had another humanity beside them for comparison. Over thousands of years, people began seeing humanity itself as separate and exceptional. Religious traditions, philosophical systems, and political structures often reinforce the idea that humans occupy a special position above the rest of life. Yet prehistory reveals a more uncertain reality. Homo sapiens emerged from a broader human family containing many branches, most now gone. We are not isolated from evolution. We are one surviving outcome among many possibilities that once existed. Ancient DNA preserved inside modern populations strengthens this realization further. Many humans alive today still carry inherited traces of Neanderthals and Denisovans. Their biology did not disappear completely. Pieces of extinct human worlds continue living quietly inside modern bodies. The line separating modern humans from other human species was never absolute. We are partly shaped by interactions with populations that no longer exist independently. This softens the image of Homo sapiens as a species standing alone through pure superiority. Humanity's survival story is more tangled, more fragile, and more connected than earlier generations realized. Perhaps the deepest lesson hidden inside this history is not that Homo sapiens conquered evolution, but that survival itself is temporary and uncertain for every species. The Earth has already witnessed the rise and disappearance of many human forms. Entire populations adapted brilliantly to their environments and still vanished eventually. Modern civilization often feels permanent because individual human lives are short compared to historical change. But from the perspective of deep time, even civilizations may represent brief moments inside much larger biological processes. Homo sapiens became the final surviving human species, not because evolution promised us permanence, but because one branch endured longer than the others under conditions that could someday change again. And somewhere beneath all modern achievements remains a quiet truth inherited from deep prehistory. Being the last surviving human species does not necessarily mean we fully understand what survival actually costs. For most of human history, the existence of other human species was completely forgotten. Ancient bones occasionally emerged from caves, riverbanks, or rocky hillsides, but people rarely understood what they were seeing. Some remains became connected to myths about giants, spirits, or strange creatures from earlier ages. The idea that humans once shared the Earth with entirely different human species seemed almost impossible because no living memory of that world survived. By the time modern civilization developed science capable of studying deep prehistory, every other human species had already vanished tens of thousands of years earlier. Humanity had grown accustomed to loneliness without realizing it. The rediscovery of lost humans began slowly during the 19th century. In 1856, workers excavating limestone in Germany uncovered unusual bones inside a valley later called the Neander Valley. Scientists eventually recognized the remains as belonging to a human species different from modern Homo sapiens. The species became known as Neanderthals. At first, many people resisted the idea. Some researchers interpreted the bones as belonging merely to diseased or abnormal modern humans because the possibility of another human species felt deeply unsettling. Over time, however, additional discoveries confirmed that Neanderthals represented a separate branch of humanity that had once lived across Europe and parts of Western Asia for hundreds of thousands of years. This realization permanently changed the human understanding of the past. Humanity was no longer a single, uninterrupted line stretching backward through time. The human family tree had branches. Archaeology expanded this picture further throughout the 20th century. Fossils linked to Homo erectus, early Homo sapiens, and other ancient human populations emerged from Africa, Asia, and Europe. Stone tools buried beside ancient bones revealed increasingly complex histories of migration, adaptation, and coexistence. Yet even with these discoveries, scientists still depended heavily on physical remains to reconstruct the past. Bones and tools can reveal important information, but they also leave enormous gaps. They cannot preserve voices, thoughts, emotions, or complete social lives. Much of ancient humanity remained invisible. Then a new scientific revolution transformed the field entirely: the study of ancient DNA. Advances in genetics allowed researchers to recover fragments of genetic material from fossil remains tens of thousands of years old. This achievement changed the study of human evolution more dramatically than almost any earlier discovery. Bones no longer revealed only physical structure. They also carried biological histories hidden inside cells for millennia. Through ancient DNA analysis, scientists confirmed that modern humans outside Africa inherited small percentages of Neanderthal ancestry. This proved beyond doubt that Homo sapiens and Neanderthals had interbred. The boundary between extinct humans and modern populations suddenly became far less absolute than earlier generations believed. Ancient humans were not entirely gone. Pieces of them survived inside living people. Perhaps the most astonishing discovery arrived in 2010 through the analysis of a tiny finger bone found in Siberia. Genetic evidence revealed the bone belonged not to Neanderthals or Homo sapiens, but to a previously unknown human population now called Denisovans. Before DNA analysis, scientists had almost no idea this group existed. Their discovery revealed how incomplete the human story still remained. Entire human populations may have lived, adapted, interacted, and disappeared while leaving behind almost no recognizable fossil record. Ancient DNA opened windows into hidden chapters of humanity that archaeology alone might never fully uncover. Technology continues expanding these discoveries today. Improved dating methods allow scientists to estimate the ages of fossils and artifacts more accurately. Microscopic analysis reveals wear patterns on tools and teeth, offering clues about diet and behavior. Chemical studies of ancient bones help reconstruct migration patterns and environmental conditions. Computer modeling allows researchers to compare skull structures and evolutionary relationships in ways impossible for earlier generations. Each advancement adds new fragments to the larger human story. Yet despite these extraordinary scientific achievements, uncertainty remains everywhere. The deeper researchers explore human evolution, the more complicated the picture becomes. Human species overlapped, interbred, migrated, adapted, and disappeared in patterns far messier than older theories predicted. The ancient world no longer appears as a simple ladder leading steadily toward Homo sapiens. Instead, it resembles a tangled landscape filled with many human branches, most now lost. Modern science has not restored complete memory of those vanished humans, but slowly, through bones, tools, and fragments of ancient DNA, humanity is beginning to rediscover the forgotten world where we were never alone. For a long time, extinct human species felt emotionally distant from modern life. Ancient bones resting in caves or museums seemed to belong to worlds completely disconnected from the present. People imagined Neanderthals and other extinct humans as populations erased entirely by time, leaving behind only fossils and stone tools. But the rise of ancient DNA research changed this understanding in a deeply personal way. Scientists eventually discovered that extinct humans had not vanished completely. Parts of them were still alive, carried silently inside modern human bodies across the world. The discovery began with a difficult question. If Homo sapiens and Neanderthals had overlapped geographically for thousands of years, did they ever have children together? For decades, many researchers doubted this possibility or assumed any interbreeding would have been extremely rare and biologically unimportant. Then genetic studies revealed something astonishing. Most modern humans outside Africa carry small percentages of Neanderthal DNA inherited from ancient interbreeding events tens of thousands of years ago. This meant that somewhere in deep prehistory, Homo sapiens and Neanderthals did not remain completely separate populations. They formed relationships close enough to create descendants whose genetic traces survived through countless generations until reaching people alive today. Suddenly, extinct human species no longer felt entirely extinct. They became part of modern humanity itself. The implications extended far beyond curiosity. Some inherited Neanderthal genes still influence modern biology. Researchers have linked certain genetic variants to immune system responses, skin and hair traits, metabolism, and even how the body reacts to sunlight or disease. Not every inherited gene proved beneficial. Some may increase susceptibility to certain modern health conditions. Others may once have offered survival advantages in Ice Age environments that no longer exist today. Evolution does not preserve traits because they are universally good or bad. It preserves whatever helps populations survive under specific conditions. Ancient interbreeding, therefore, became part of the biological toolkit Homo sapiens carried into unfamiliar northern climates outside Africa. The story grew even stranger with the discovery of Denisovans. Scientists first identified Denisovans not through a complete skeleton, but through DNA extracted from a tiny finger bone found in Siberia. Genetic analysis revealed a human population distinct from both Homo sapiens and Neanderthals. Soon, researchers discovered that some modern populations, especially in parts of Oceania and Southeast Asia, inherited Denisovan ancestry as well. Once again, this meant ancient encounters between different human species had produced descendants whose biology continued into the present. One particularly important Denisovan-derived gene helps modern Tibetan populations survive more effectively at high altitudes with lower oxygen levels. This adaptation may have originally evolved among Denisovan populations living in mountainous regions long before Homo sapiens arrived there. In a very real sense, extinct human species contributed biological knowledge to modern humans through inherited DNA. But the farther science explores human evolution, the less stable those categories become. Humanity's past appears increasingly fluid, interconnected, and unfinished. Species boundaries blurred, populations mixed. Evolution unfolded through migration, adaptation, isolation, and reunion over immense spans of time. The ancient world was not organized cleanly around one inevitable path leading toward modern civilization. It was filled with experiments, branches, and possibilities, most now gone. Perhaps the strangest realization of all is that Homo sapiens may never fully recover the complete memory of the human family. Too much time has passed. Too many traces disappeared forever. Entire human lives unfolded without leaving fossils, names, or stories behind. Yet fragments continue surfacing from the earth, slowly reminding modern humans of something forgotten for tens of thousands of years. The world we inherited was once shared by many kinds of humans, and even now, we may still know only part of their story. When modern humans look into a mirror, it is easy to feel as though humanity was always meant to look this way. One species, one surviving branch, one continuous story leading from ancient ancestors to modern civilization. But deep history tells a quieter and far stranger truth. For most of human existence, Homo sapiens was not alone. The Earth once carried many human species at the same time, different populations shaped by different climates, landscapes, and evolutionary paths. Some survived frozen northern winters, some adapted to isolated islands, some crossed mountains, forests, and ancient grasslands long before recorded history began. Humanity was once broader than memory itself. Over millions of years, the human family expanded into many forms. Homo erectus spread across enormous distances and survived longer than our species has existed so far. Neanderthals endured Ice Age Europe with bodies adapted to cold environments and lives built around cooperation, hunting, and survival. Denisovans left behind genetic traces, still living inside modern populations despite leaving very few fossils behind. Other human groups appeared briefly in isolated regions, adapted in unexpected ways, then disappeared almost entirely from the historical record. Each branch represented a different possibility for what being human could become. Yet none of those humans knew they were part of a larger evolutionary story. They did not know their species' names. They did not know which branches would survive or vanish. They woke beside fires, searched for food, protected children, feared injury, adapted to changing weather, and moved through landscapes shaped by forces far beyond their control. Their lives unfolded moment by moment inside the uncertainty of the present, just as modern human lives do today. Looking backward now creates the illusion that Homo sapiens was always destined to remain. But destiny rarely appears anywhere inside the fossil record. The survival of our species emerged from countless fragile moments shaped by climate, migration, cooperation, adaptation, and chance. If circumstances had shifted slightly differently, another human species might have survived instead. Or perhaps several human species might still exist together today. That possibility changes the emotional meaning of humanity itself. Modern people often think of humanity as singular because no living memory remains of the crowded human world that existed before us. Yet ancient DNA quietly reminds us that the separation between modern humans and extinct humans was never complete. Many people alive today still carry inherited traces of Neanderthal or Denisovan ancestry. Fragments of older human worlds continue living silently inside modern bodies. The extinct humans did not vanish as cleanly as earlier generations once imagined. They remain part of us biologically, even after disappearing as separate populations. This realization softens the boundaries humans often place around themselves. The human story becomes less about one superior species rising above all others, and more about a tangled family history shaped by overlap, coexistence, loss, and survival. Deep prehistory also changes how modern humans understand loneliness. Homo sapiens has lived alone as the only surviving human species for tens of thousands of years, long enough for coexistence with other humans to feel unimaginable. Yet from the perspective of evolutionary time, this loneliness is relatively new. For most of human history, being human did not mean being alone on Earth. Other minds once looked back at the same stars. Other human hands shaped tools beside ancient fires. Other populations developed ways of surviving environments modern humans might struggle to endure. Entire forms of human experience disappeared before civilization began recording memory, and perhaps that is why the rediscovery of extinct human species feels emotionally powerful even today. Their bones remind modern humans that humanity is not fixed or singular in the way people once believed. We are part of a much older and more uncertain story than civilization usually remembers. The world that produced Homo sapiens also produced many other humans, most now gone. Their disappearance does not make them failures. Their existence reveals how experimental, adaptable, and fragile human evolution has always been. And somewhere beneath all modern technology, cities, and achievements, Homo sapiens still carries the inheritance of that ancient, uncertain world. A world where survival was temporary, identity was fluid, and humanity itself existed in many different forms beneath the same sky. The discovery that many human species once existed changes more than scientific understanding. It changes the emotional position of modern humans within nature itself. For centuries, many people imagined humanity as something sharply separated from the rest of life, a single unique species moving steadily upward through history. But deep prehistory reveals a more uncertain reality. Homo sapiens emerged from a wide and branching evolutionary family, not from a straight line leading inevitably toward modern civilization. We are not standing outside evolution, observing it from a distance. We are one temporary result within it. This realization reshapes how people think about identity, intelligence, survival, and even human importance. Modern civilization often encourages the belief that humans are defined mainly by technology, language, or abstract thought. Yet extinct human species challenge these boundaries. Neanderthals used tools, controlled fire, cared for injured individuals, and adapted successfully to difficult climates for immense stretches of time. Denisovans contributed genetic adaptations, still helping some modern populations survive at high altitudes today. Other ancient humans crossed dangerous landscapes, raised families, cooperated socially, and transmitted knowledge across generations long before recorded history began. Many behaviors once considered uniquely modern now appear older and more widely shared across the human family than earlier generations assumed. This does not erase the achievements of Homo sapiens. Modern humans eventually built civilizations capable of science, art, engineering, medicine, and global communication on scales unmatched by earlier human species. But deep history warns against interpreting these achievements as proof that Homo sapiens became somehow separate from biology or immune to evolutionary pressures. Intelligence does not guarantee permanence. Adaptability does not eliminate vulnerability. Every extinct human species once survived successfully too, until environments shifted beyond what their populations could sustain. The human story, therefore, becomes less triumphant and more reflective. Civilization appears not as the final destination of evolution, but as one phase inside a much longer process still unfolding. There is also a quieter lesson hidden inside this history about how humans understand difference. Today, all living people belong to the same species despite enormous cultural and physical diversity. Yet ancient humans once encountered populations biologically more distinct than any modern human groups are from one another. Homo sapiens survived partly through coexistence, competition, migration, and interbreeding with other human species. The idea of absolute separation between human groups becomes difficult to maintain once the deeper evolutionary story is understood. Ancient DNA already demonstrates that modern humans carry inherited traces from populations once considered entirely separate from ourselves. Humanity's history is deeply interconnected at levels older than civilization itself. This perspective may also change how modern people think about loneliness. Homo sapiens has lived as the only surviving human species for so long that human uniqueness feels natural and permanent. Yet evolutionary time tells another story. The world once contained multiple forms of humanity living simultaneously. Some populations may have viewed one another with curiosity, fear, recognition, or misunderstanding. That entire shared world vanished before written memory began. Modern humans inherited its silence without realizing what had been lost. In a strange way, the rediscovery of extinct human species reconnects humanity to forgotten relatives erased by time. At the same time, deep prehistory introduces humility into the modern view of civilization. Humans today possess extraordinary technological power, yet the existence of extinct human species reminds us that survival can never be fully separated from environmental stability. Climate shifts, disease, migration pressures, ecological change, and social resilience shaped every earlier human population. Those forces continue influencing humanity now, even if technology sometimes obscures them temporarily. The disappearance of other human species becomes more than an ancient mystery. It becomes a reminder that no species, no matter how adaptable, receives permanent guarantees from evolution. Perhaps the most meaningful insight hidden inside this story is not that Homo sapiens conquered the Earth, but that humanity itself has always been more fluid, fragile, and interconnected than modern civilization usually remembers. The people alive today are the descendants of one surviving branch, carrying traces of older human worlds inside them. Our species inherited not only genes from the past, but also the uncertainty of a long evolutionary journey shaped by forces no population ever fully controlled. And somewhere beneath all modern identities remains an ancient truth that deep history keeps quietly repeating. Being human was never one fixed condition. It was always changing. Tonight, the modern world feels crowded with human activity. Cities glow through the darkness. Voices travel instantly across continents. Billions of people move through lives connected by technology, memory, language, and shared systems built over thousands of years. It can feel as though humanity has always filled the earth this way. But deep beneath modern civilization rests a quieter history almost forgotten by time. For most of the human story, Homo sapiens was only one branch among many. Other humans once walked through forests, crossed frozen plains, sheltered inside caves, cared for children beside ancient fires, and looked toward the same night sky without knowing their worlds would eventually disappear. Their names were never written down. Their languages vanished long before memory. Most left behind only fragments buried beneath stone and soil. Yet they were human in ways modern people are still slowly learning to understand. Over millions of years, evolution produced many different forms of humanity. Some adapted to extreme cold. Some survived isolation on distant islands. Some carried genetic traits that still remain inside modern populations today. None of them knew whether their species would survive. None of them understood the larger evolutionary story unfolding around them. Like all living creatures, they existed inside the uncertainty of the present moment, responding to changing climates, fragile ecosystems, illness, migration, hunger, and time. Eventually, every human species disappeared, except one. Homo sapiens remained, but survival did not erase the others completely. Ancient DNA still carries traces of Neanderthals and Denisovans inside many people alive today. Their existence continues quietly within modern humanity, woven invisibly into the biology of the only surviving human species left on Earth. Science continues uncovering pieces of this forgotten world through fossils, archaeology, genetics, and new technologies. Yet much of the story will likely remain incomplete forever. Entire generations of ancient humans lived and died without leaving recoverable traces behind. Their thoughts, voices, fears, and memories vanished with them. The deeper researchers look into human origins, the clearer one truth becomes: humanity was never as singular or stable as modern civilization once believed. The Earth has already witnessed many forms of being human. This history carries an educational lesson that extends far beyond curiosity about the past. It reminds modern humans that survival is not guaranteed, that intelligence alone does not create permanence, and that civilization exists within environmental systems far older and larger than ourselves. Every extinct human species once adapted successfully to its world. Many survived for hundreds of thousands of years. Yet, changing conditions eventually reshaped their future in ways no individual could fully predict or control. Homo sapiens inherited the Earth not because evolution declared us perfect, but because one fragile branch endured while others slowly faded away. Perhaps this realization can also create a quieter form of humility. Modern humans often divide themselves by borders, languages, beliefs, appearances, and identities. But deep history reveals that every person alive today belongs to the same surviving species, connected through ancient migrations, stretching back into a time when humanity itself existed in many forms. The differences people focus on today are small compared to the distances that once separated entire human species sharing the same planet. And still, those ancient populations sometimes cooperated, exchanged knowledge, and even became part of one another through shared descendants. Somewhere beneath modern life remains the memory of that interconnected human past. Maybe the deepest meaning of this story is not about extinction at all. Maybe it is about perspective. The existence of many human species reminds us that humanity is part of nature, not separate from it. We emerged through the same evolutionary processes shaping every living thing on Earth. Our technologies, cities, and civilizations our recent moments inside a much older biological history still continuing now. The future remains uncertain, just as it always was for the humans who came before us. And perhaps, as sleep slowly approaches tonight, there is one final question worth carrying quietly into the darkness. If another human species had survived beside Homo sapiens until today, would modern people still understand what it truly means to be human?